Here we have a SAT math problem. Okay, let's go to the question. The figure above shows two squares and a circle. If the length of PS is A, what is the area of the shaded region? So we have to find the area of the shaded region we have over here inside the circle. That is between the circle and the smaller square. And we have the length of this line segment PS. That is the length of the side of the bigger square that is given over here is A. Okay, now let me draw the diameter of the circle over here. So here I've drawn diameter clearly. So the diameter is parallel to one of the sides, that is the side PS of the bigger square. Since the length of this side of the square is A, so the diameter is also the same A. Then what is the radius of the circle? Then the radius has to be half of the diameter. That is half of this A. That is A divided by 2. Okay, let me draw the radius of the circle. So here I have drawn the radius of the circle. So here this is the center point of the square and also center of the circle, and this line segment represents the radius of the circle because it connects between the center and a point of the circle. So the radius of the circle is A divided by 2. And now let me draw a horizontal line over here to form a right triangle. So here we have a right angle. And since this is the center point of the smaller square, whatever length we have for this line segment, the same length we have for this line segment and this line segment. Okay, let me assume x as the length of this line segment, then the length of this line segment also x. So for this one also we have x. Now the length of the one side of the square is 2x. Okay, now what I'm going to do is I'm going to use Pythagorean theorem in this right triangle over here. So that is sum of the squares of two legs equals to square of the hypotenuse. Here this x and x, both of them represent the two legs, and this a over 2 represents the hypotenuse because it's opposite to the right angle. So sum of the squares of two legs x square positive x square equals to a over 2 the whole square, that is the square of the hypotenuse. When I combine this x square positive x square, I'm getting 2x square, and when I simplify this one, I'm getting a square, that is I'm distributing this exponent 2 for numerator and denominator. So when I distribute this exponent 2 for denominator, I'm getting 2 square is 4. Now let me multiply both sides of this equation by 2. Okay, let me do it. So when I multiply this 2x square by this 2, I am getting 4x square on the left side. On the right side, when I multiply this a square by 2, I am getting 2a square divided by 4. Okay, here we have a question. Why do I get the stuff that is equivalent to 4x square? There is a reason. Already we know that the length of one side of the smaller square over here is 2x, and here also we have 2x, because in a square all the four sides are equal. Now to get the area of this smaller square, what I have to do is I have to multiply the side by side, that is 2x by 2x. When I multiply 2x by 2x, I am getting 4x square. So this 4x square gives the area of the smaller square. Therefore the area of the smaller square is 2a square divided by 4. Okay, now what I'm going to do is I'm going to find the area of the circle. Let me write over here, area of circle. So we know the formula to get area of a circle, that is pi times r square, pi times, and this r represents the radius. Already we got the radius of the circle, that is a over 2. We can plug in a over 2 for radius over here. Then I'm getting pi times, when I square the numerator and denominator, I'm getting a square divided by 4, or it can be written as a pi a square divided by 4. Okay, now I got the area of the circle and also area of the smaller square. To get the area of the shaded region, what I have to do is I have to subtract the area of the smaller square from the area of the circle. So the required area, that is area of the shaded region, is equal to, so subtract the area of the smaller square 2a square over 4 from the area of the circle. Let me write it, pi a square divided by 4 negative 2a square divided by 4. Okay, now we have the same denominator for both the fractions, so we can take this 4 as a common denominator. Then I'm getting pi a square negative 2a square. Okay, here when I consider the numerator over here, both the terms have the greatest common divisor a square, so we can factor a square out. When I factor a square out, then I'm getting pi negative 2 inside the parenthesis divided by 4. So this is the area of the shaded region in the given figure. We find this of a square times pi negative 2 over 4 in answer choice A. The correct answer choice for this question is A.